So this is a question I always ask before I talk. Who's running Cassandra in production? Very good. Who has a Netflix account? Who's running Netflix in a country you're not supposed to? Oh, good. Well, so this morning we're going to talk about, well, the title State of Zen, Chaos Monkeys, and Cassandra. I'm going to start by telling you guys a little bit of a story this morning. Last year, Cassandra Summit was early September. I believe it was September 11th. And something happened a week or so after that talk. And we're going to talk a little bit about that incident. And then I'm going to hand it off to two of my senior software engineers who will tell you a little bit about our automation stack and how we handled that event. But first, my name is Christos. I lead cloud database engineering at Netflix. And today, I think you're all very lucky to get Jean-Sébastien Janot and Nir Alfani, Alfazi, sorry, who are the engineers building, who maintain the old automation framework and are building the new automation framework. So let's get started. Back to the story. It was a Wednesday, a couple of weeks after the Cassandra Summit last year. And we got an email from AWS telling us, hey, we're about to reboot the whole EC2 fleet across the world. And that was interesting. That was very interesting. It was named AWS Reboot or Reboot Apocalypse. Now, anyone who gets really bad news goes through 5 stages. They're called the 5 stages of grief. And so, just like in the 5 stages of grief when you get very bad news, we had very similar reactions. So on Wednesday, they told us starting Thursday and for the next 4 days, we're going to be rebooting EC2 instances. Well, our Cassandra fleet runs on EC2 instances. So our first reaction was denial. No, they can't be doing this. This is ridiculous. This is AWS. This doesn't happen. Well, it turns out it was going to happen, whether we liked it or not. And the reason was a security flaw in the Zen virtualization software they use to cut out EC2 instances on their hardware. So obviously, the next stage was anger. For lack of a better word, we were pissed. Are you kidding me? You're going to do this? We actually have a party set up in Los Angeles to celebrate our 50 million users. And now we're all going to miss this party, and it wasn't a good end of a Wednesday to be a Netflix CDE employee. So then we went through the bargaining phase. We called up our TAM and said, hey, look, please, don't do this. We've got like a trip planned. Can we push this out a week, or at least stage it out over more than 4 days? And of course, their response was, nope, this has to happen. So of course, the next step is depression. I basically told the guys, hey, we might want to update our resumes and maybe go see the people at the Apple booth for a job, because if this all goes down and goes to hell, well, there might not be a Netflix come next week. But the final stage of grief is acceptance. And it wasn't an acceptance, it wasn't a capitulation of we can't do anything about it. It was more of an acceptance of, wait a minute, we test for this. So maybe we're going to be all right. Well, how do we test for this? A lot of you probably have heard of the Simian Army. Chaos Monkey, which made a cameo yesterday during the keynote. Chaos Gorilla, and Chaos Kong, where we evacuate all traffic from one AWS region to another to ensure continuity when there's events like this weekend's DynamoDB outage. So about a year and a half ago, we've started pointing Chaos Monkey not only to our stateless systems, but to our stateful systems. We turned on Chaos Monkey on our Cassandra fleet. And with Cassandra being as fault tolerant as it is, and with the automation that we built, a lot of you have probably seen this logo before. We've proven that Cassandra can actually withstand a monkey attack. And if you think about it, AWS Reboot was basically a monkey exercise on steroids. So Thursday came along, started doing the first set of reboots, and things looked pretty good. Then they did another zone, and we started building our confidence that, hey, maybe we can go to that party over the weekend. And Friday night, we were all still on standby, and we decided, hey, no, let's do it. It's working, everything's fine. So we all hopped on planes and went to LA and had a good time. We hung out with Snoop Dogg and R2D2, and it was lots of fun. So Monday morning comes along. All the reboots were done. And the total was 218 Cassandra nodes got rebooted. 22 didn't come back. And so our automation detected it, found out why it didn't come back, and initiated auto remediation. And the Cassandra, the instances were restarted, data streamed to the new nodes, and Netflix suffered 0 downtime. That's one heck of a, that's one heck of a feat. So I'm going to now give the stage to Jean-Sébastien, who is going to talk a little bit about what the stack looked like back last September. And then he'll be followed by Nir, who will tell you about what the stack looks like today and how we leverage a new product called Stackstorm. And they have a booth here. You can go check them out. And how we're evolving that stack to be able not just to handle our Cassandra fleet, but our Elastic fleet and our own homegrown DynamoDB fleet. So I'm going to give the stage now to Jean-Sébastien.
Everybody hear me okay? Cool. So Christos, I'm sorry, I'm going to have to correct you on one thing. You talked about the 5 stages of grief. There's actually 6 stages, and the 6th one is implementation, and that's when I come in. So I'm going to start by talking about what our stack looked like at the time, our automation platform. On the left, you're going to see a Cassandra cluster, a classic Cassandra cluster. The only difference that you might not have on your clusters is the preamp process. Preamp process is taking care of maintenance operations on the cluster, for example, repair and compaction. And it's also taking care of token management. When a new node comes in, it's going to take care of assigning a token to it and let it join the cluster. On the right, what you see is a standard Jenkins installation with a bunch of Python scripts underneath. This is what we had during the reboot 2014. So you probably are wondering, is there something missing here? So we don't have any system doing the monitoring. So you probably know about Ops Center. At Netflix, we don't use Ops Center. At the time when we started using Cassandra, Ops Center was non-existent. So we used Preamp and what we call, our own monitoring system, which is called Atlas. It's open source now, you can look it up. This is a standard dashboard for our Cassandra clusters. Every few quarters, we reassess Ops Center to see if we're going to use it in the next version. But so far, we've been using Atlas, and one of the reasons for that is that, as you can see, on the top right corner is our Atlas clusters. we have pream that is responsible for sending the metrics to Atlas. So it sends heartbeat and sends a lot of metric about coordinator latency and all the other metrics are used to drop messages, Cassandra exceptions, and all in all. And on the left, you can see our Netflix apps. Netflix apps are also sending metrics to Atlas, the client-side metrics. How is the STNX latency looking, and the client view of the system. Here's an example graph. You'll see that we can put on the same graph client-side and server-side metrics, which give you a good idea of how the system reacts to the server-side latency. All the blue lines are client-side latency, the STNX latency, the 99th percentile for read. And we have multiple lines because we check the latency on the column family and key space level. And the red one is the server-side latency. So now that I've explained the monitoring system that we have, there's another way we monitor our fleet of Cassandra is called our health check script. The health check script is run through Jenkins. It's more of a pull approach. It's going to contact all the clusters, all the nodes, and make a deep diagnostic to see if there's anything going wrong. I'm not going to go through all this slide, but focus on green and red. Green good, red bad. That's pretty simple. So good means nobody got paged, and the health check either didn't see any problem or saw a problem and fixed it automatically. So, and red is we got a problem, we couldn't fix it automatically, so we were going to page an engineer. The two cases that we had automated at the time was an instance that disappeared. For example, Chaos Monkey just terminated one of our instances, or it got rebooted or something like that. And the other cases, I won't go deep into it, is if there's any I/O issues on the disk, so there's nothing we can do, the drive just failed. The ephemeral drive failed, so let's just terminate the instance. But for all the other cases, at the time, we just paged an engineer. So what about reboot? So during reboot, it's kind of a mix of a Chaos Monkey exercise and just a single reboot instances, because like Christos said, some of our instances never came back. They got rebooted, but the EC2 health check, Amazon health check, actually contact the nodes internally, and if the node doesn't respond, it terminates them. So some of our instances were so old that they got terminated because of that. So what does it look like for our workflow? So the instance disappeared because it never started back again. So we detect it, we launch a new instance. The process of launching a new instance is, for those of you familiar with AWS, we have auto-scaling groups with normally controls a fleet of server that can dynamically scale, but for Cassandra, we keep it stable. We just tell them we need 6 nodes in that zone, so we're gonna have the ASG configured with 6. If we detect that there's only 5 nodes, then we're gonna tell the ASG, please enable scaling. It'll launch a new node and then disable scaling. And then we are all good because the node joined the cluster and we detected it, so no pages. The other cases is that the instance gets reboot, but it actually comes up. And on the first time, the first check looks at it and there's an instance missing, but it's not missing out of the ASG. The ASG is full, there's 6 instances. But when we do a ring command, a node tool ring, we see there's a node that is down. So what do? We start looking at why is it down. So we go through all these steps, and actually there is actually a node that is down. It's not, the Cassandra process is not running because the timing of the health check actually caught it while it was rebooting. So how do we make sure we don't page an engineer for that case? Because actually we don't need to page, just need to wait a little. That's actually what we already do. There's always transient failure in the cloud. Sometimes there's a node going down, but if you wait 10 seconds, it'll just gonna go back up for any network issue or disconnect. So this process, I actually have a stage which is it the first time it failed? And then if it's the first time this workflow is failing for that node, it's going to sleep for X minutes. At the time, it was 10 minutes, but for reboot, the only thing we changed before going to the party was switch a configuration to say, let's give it 20 minutes, because we know there's going to be a lot of reboot, and it might take longer to reboot them. So we changed that setting, and we went off to the party, and it worked. So we got, I was about to say we got lucky, but I mean, we planned for that. But we got lucky that that only one zone at a time was affected, because that would have been a different story. So that's our stack at the time. We identified a couple of gaps when we went through Reboot, and even before that, we were already planning on the next system. One of the gaps that we had was the fact that our automation system was a big monolith. It was a big bunch of Python scripts and Python library that we cooked up, 100,000 lines of Python. So it's very hard to actually have a new hire comes in, look at all this code, and get actually familiar with that automation platform. And with big monolith come lack of chaining. The fact that it was a big monolith, we prefer system to be more smaller pieces that are chained together and that trigger, on success trigger this one. More like the workflow that you saw earlier for the health check, a system that is based more like a workflow instead of a big script with conditions and all. The other big gap, this is actually a picture of our Netflix data center, the power cable. So we're hoping nobody will trip on it. No, just kidding. But what I want to illustrate by this is single point of failure. The Jenkins Master was our single point of failure. If the master goes down, all our script that was currently running will page the engineer. So we wanted to reduce these false positives. And yes, there was a way to have a multi-master Jenkins, and there's always plugins that you can do to, but we wanted to go back to the basics. Like, we want more of a cluster solution. We're working with Cassandra, so we know about high availability. We want our monitoring system and automation system to have high availability. So with all of these gaps, I'm going to hand it off to Nir, who's going to talk about how we actually fix those gaps and what the new system looks like. Thank you very much.
Can you hear me? Oh, great. Thanks, Jess. So we decided to embark on a new journey to figure out how we're going to fill in those gaps. That in mind, we didn't want to lose all the principles and lessons learned we had so far. That health check script that you just saw a simplified version, a diagram of it. It actually handles lots of edge cases, and throwing it all away would be a shame. It's definitely not what we wanted to do. So we were looking for something that would both accommodate filling in those gaps, but keep the stuff that we already implemented in place. So we started by going out there and talk to other companies, see what they're doing. So we went to Facebook, spoke with their engineers about FooBar. FooBar is a system that they designed that detects machines that have experiencing all kinds of issues in production and automatically takes them out of the fleet in order to heal them. We also went to LinkedIn and met with their engineers and spoke with them about Nurse. Nurse is a platform that they also built in-house to do all kinds of auto remediation things. And we were in touch with Dropbox engineers as well, speaking with them about Noro. Noro is an open source project hosted in GitHub, if I'm not mistaken, with kind of similar capabilities of self-healing and auto remediation. In addition to that, we also started looking outside for all kinds of open source projects that would fill in our requirements, checking different stuff, running proof of concept, and then we had to come with a decision. Do we build our own in-house solution or adopt something that already exists there, of course, contribute to it and enjoy it? And we decided to go with Stackstone. Stackstone is an event-driven automation platform. It has lots of capabilities. We mainly use it for auto remediation, but it also has additional capabilities of providing audit trail, integration to chat ops, and many other things. As Christos mentioned, they have a booth right here. Go them, ask them questions. They're great guys. They have a great community. Join in and contribute. You'll have fun. So let's see how Stackstone integrated into our stack. So that's the slide that we saw before with Jenkins running remotely scripts on the right side on our Cassandra fleet. Our Cassandra fleet reports metrics through Preem. Preem gathers metrics through JMX from Cassandra, send them up to Atlas, our telemetry system, And in addition to all Netflix environment, all the services from Netflix environment also reports metric to Atlas. And if Atlas detects any kind of weird behavior or that something's wrong, it hits PagerDuty API in order to page our on-call. So now instead of Jenkins, we have a cluster of Stackstorm. We actually didn't totally, to be honest, we didn't retire Jenkins totally. We still have some scheduled tasks like repairs and compactions that are still running. But now, instead of hitting PagerDuty whenever there's an issue detected, Atlas is going to send an event to Stackstorm. Stackstorm has a really fancy rule engine that can figure out which rule it should detect for that event. And by choosing that rule triggers either a single action or a workflow, which is a chaining of actions. Each action depends on the result of the previous action. So you have a full workflow of if, else, depends on the previous result. That way, it's much easier to auto-remediate things. I wanted to provide as an example a disk usage alert that we used to get. So if previously it would just page the on-call, right now Stackstorm received that disk usage alert event, and it goes and gathers additional context. By additional context, I mean things like, is there any offline process running? Are compactions running? When compactions are running, as most of us know, data size may increase, maybe even up to double. So if compactions are running, maybe we shouldn't page the on-call. We can just send an email. That's a clean win for the operations. They're getting less pages. So that's already one good thing. But how does it fill all the gaps that we discussed before? So remember the monolith part? So now instead of having monolith scripts, we have to break them down into smaller chewable actions that can be reused in different workflows. So breaking down the monolith is already a win. Another win is chaining of action. It's not natural to chain Jenkins jobs, but it's much easier to chain them using a workflow. And as for the single point of failure, we run Stackstorm in a cluster. When Atlas triggers an event, one of the instances of Stackstorm instances will take that event and handle it. So even if a machine goes down, another machine might pick it up. So as long as we have one machine that is functional in that cluster, the event will get handled. So that's another win for the resiliency. But if we can't auto-remediate, we can still use PagerDuty to page the on-call. But here is still another big win. And why is that? Because Stackstorm, by collecting all that additional context and information, it can check out stuff like the ring output. It can check stuff like offline maintenance running. It can provide links to relevant dashboards and things like that. So by the time the on-call reaches his or her computer, they'll already get an email from Stackstorm with all that additional information. So time to resolution will be reduced. So that's another huge win. Now is a part that is personally important to me in that presentation. Remember I was talking about all the principles and lessons learned. I want to go over a few of them with you. Hopefully you'll be able to take something with you and make your processes and your system more resilient. The first principle is making your processes idempotent. An idempotent process means that you can run it multiple times, but it will only be applied as if it was running once. Now, the good thing about that is, imagine you're upgrading a fleet of 200 nodes. And after 150 nodes, the process crashes. Oh, what do we do now? Start to manually run remotely, check which versions are on which node, which ones we need to upgrade. Not so fun from an operational perspective. By making your process idempotent, you can simply run it again. And having it idempotent here, the implementation of idempotency is actually something really simple. Before you start upgrading a node, just ask a simple question. What is the version that's running on that node? Running node tool version, is it the desired version? If it is, just keep on and move on to the next node. By doing that, we save a lot of time, a lot of resources, we gain resiliency. So that's a huge win. One more thing to keep in mind, making your process idempotent could be even better if you break it into steps and make each and every step idempotent. JS put it nicely when we spoke a couple of days ago. He said that idempotent means making a stateless system feel stateful. Think about it. It's a nice sentence. Second principle, simplicity. That one might be the hardest one to implement because taking a complex system and making it simple requires some kinds of geniussy. So it's not always feasible. But it's a good principle to keep in mind whenever you design a new system. If you can avoid multiple steps or do anything simpler, it's always a win. Mostly from operational point of view, but also from maintaining the code and etc. The combination of simplicity and idempotence is really powerful. An example that I wanted to bring you here is what we call the Netflix resumable repairs. Same like the upgrades that we discussed before, running a repair on a 300-node cluster could take a while. It could take, say, 7 days. If after 5 days the Jenkins job crashed, no problem, repair is idempotent, right? We can run repair on a node multiple times. So we'll just run it again. This time, after another couple of days, the Jenkins job crashed again. So now we're 7, 8 days into the process. Say that one of our column family has a GC grace period of 10 days. What does it mean? Does anyone here have an idea? I need your help. GC grace period is about to expire. Some of the nodes weren't repaired. There are tombstones there. Data resurrection. We're in the danger of data resurrection. Thank you very much. So JS came with a simple yet brilliant idea of, before running a repair on the node, just check which Jenkins build number was last run on that node. This way, if a process crashes, we can simply run it again with a resumable repair ID. And by checking that ID and comparing, we don't need to rerun it on the same node. So all the nodes that were already repaired will quickly get skipped, and we'll start exactly from where we stopped. So it won't take, again, 7 days to repair the whole cluster. Another lesson learned is that we moved from using remote SSH synchronous connections to async HTTP connections. Again, repairs. This is a long-running process. There are a lot of long-running process that we run. And by having a synchronous connection, your process becomes more vulnerable to transient network issues, for example. It can easily fail. By using async HTTP request with either callbacks or pooling, you make your process more resilient. Also, moving from SSH to HTTP, there are many libraries out there that support it. It's easier to test, so we increase developer velocity by doing that. Tuning your timeouts and number of retries. Whenever we work with remote services, that's something that we always have to keep in mind. It depends on the service that we're working with. One important thing to note here is also the sleep in between the retries. This is something to take into account. A good practice is using exponential backoffs, meaning that if the first try failed, you sleep for a second. Then if the next try failed, you sleep for 2 seconds, and then for 4 seconds, and etc. The reason for that is to avoid what is called a retry storm. If all the clients keep hitting the servers with retries without sleeping, the server will be overwhelmed and might fall back. And last principle I wanted to go over is using fallbacks. Some of you might have already used fallbacks without even realizing it by trying to get some kind of configuration or something from a remote service. The request failed, and you default to hard-coded value. That's called serving a fallbacks. In Netflix context, most of you probably know that there is the personalized recommendation engine. So when you log into your Netflix account, you see personalized recommendation. If that service starts to become latent or even falls down, you wouldn't get 404, which would be a horrible customer experience. Instead of that, we default to some kind of general global recommendation service. This way, Most of you would probably won't even notice the difference. You keep getting served with a nice page. You can hit the movie, the play button, and watch the movie and enjoy Netflix. I'd like to wrap up with our plans to the nearest future. So all the time we keep brainstorming and thinking what else we can do better. How can we improve our platform, our automation services, and make them even more resilient? One thing we came up with is to start gathering data, collecting metadata about the clusters, all kinds of statistics. This way, we'll be able to try to predict things when they happen, even before they happen, sorry. By being proactive instead of reactive, we can make our platform more resilient. Take the disk usage example that we just discussed. If our auto-predicting platform can detect that we're going to run out of disk usage, it can trigger an event in Stackstorm to scale up the cluster. This way, we won't even get page. We'll just avoid the failure to begin with. So that's a huge win for resiliency. And it's also a huge win for the quality of sleep of our on-call. Thank you very much, guys. Now is the time for questions. JS and Christos, please join me. Please raise your hand. And is there someone with a mic? Oh, great.
So how do you handle one of the Stackstorm node failures when it is in the middle of a workflow execution?
We can't hear you.
We can't hear you.
Speak louder, closer to the mic.
How do you handle one of the Stackstorm node failures when it is in the middle of running a workflow doing remediation for?
Yeah, how do we handle if Stackstorm fails? Actually, right now, we get page. Eventually, we'll probably have try to have a way to make it auto-heal, but right now, it's configured with auto-scaling in mind. So if an instance gets killed or anything, it'll bootstrap and join the cluster. So far, we haven't had any issues, but we'll see what future holds.
Yeah, I was more interested when it is running a workflow. For example, you are remediating your cluster, and if it goes down.
Okay.
I'll take that. So as we said, the workflow, each action result might trigger a different action in the workflow. You can define in each workflow on success or on failure scenario. And on failure scenario, it could even mean that your script crashed. Okay, so even if something went that bad, the on fail will still get run, and you can leverage it to either page your on-call or send an email. That's what we currently do.
Thank you.
Good question.
Hold on, Mike is coming.
I was just wondering, how large is your staff that supports the Cassandra?
So CD as a whole is about 11 strong, but that's Cassandra. 9,000 nodes of Cassandra, 281 clusters. That's about 4,000 Elastic nodes and about 500 to 1,000 Dynamite nodes. So a staff of 11 handles all these distributed databases.
Thank you.
And just one extra clarification. I know the guys talked about operations. We don't have an operations team. Everyone in the team, whether developers or whether they're working on this stack, take a turn on call. So when we say operations, that's actually everyone. And that's how all teams are set out in Netflix.
Yeah, we eat our own dog food.
Do you use open source version or DataStax version of Cassandra, and which version?
We can't hear. We can't hear that.
Do you use open source version or DataStax version of Cassandra?
Oh, we use DataStax Enterprise.
And how frequently you upgrade your clusters?
We try and do it once a year at 9,000 nodes. There was a question over here. Or yell it out. Oh, okay.
Have you had any issues where the schema that you designed in the Cassandra cluster had to be changed because maybe some queries were slow, and I don't know if none of that was discussed as far as operations go, but I'm curious if that became an issue with.
So the questions: do we ever change our schema?
Yeah, is your schema sort of updated regularly based on performance, that sort of thing?
Yeah. So I mean, applications. When there's a new application and we spin up a cluster for them, and most applications have their own dedicated cluster, we come up with an initial schema. Applications evolve, new features get added. So yeah, we reevaluate the schema on a regular basis. And there's members on our team who are really great at schema design, NoSQL schema design. It's specifically Cassandra schema design. And part of what cloud database engineering does is offers consultation and best practices.
When you do upgrade your Cassandra clusters, do you generally go to the newest, or do you stay more on older stable version?
So the question is, when we upgrade our Cassandra fleet, do we go to the latest, greatest? So are we running 3.0, or do we take a step back? Well, DataStax Enterprise, which is what we run, out of the box is a version behind. So we run the latest DataStax Enterprise, which in of itself is about a version behind.
Out of the 200 servers that I believe you had originally at the time of Reboot, you mentioned 22 didn't come up. To me, that seems like a high number, like 10% of your servers didn't come up after Reboot, and I didn't quite catch the reason. What was the reason why? Was there one common issue that didn't come up, or is it just random stuff?
Yeah, this was because at the time, sometimes we have Cassandra instances are long-running instances, and some of our instances were 2.5 years old. And at that time, there was a very old hardware, and sometimes when they reboot, their boot sequence was too long to actually come up properly. EC2 has a timeout on this, and if they don't boot up in under 20 minutes, they just terminate them. So they got terminated by Amazon before they ever reached out.
Some of those nodes were still on a Linux 2.6 kernel.
Yeah.
Hi, Sharat Sahadevan. My question is, generally I see the industry moving towards the cloud. You talk about the incident with AWS where you had no control of when they were going to reboot. Well, if I have my own data center today, I have control over that. Where do you see the industry going, and how do you think things will play out?
Yeah, so even your data center, you don't have control when what state are you in? Are you in California? Well, when your utility company, I was going to say PG&E, when your utility company has a problem, or some vandal cuts a fiber cable and all internet is affected. So it's a false sense of security to say, I have my own data center, I control my destiny. So whether you're in the cloud, whether you have your own data center, you have to test and you have to architect for disaster recovery and fallback, ideally.
I think a lot of companies do that today. But the question I have is, here you are, a company as well known as Netflix, but you had no leverage against your provider, with all your customers could have been impacted. I mean, that I think is, from a customer service perspective, control that some companies would not want to lose.
So actually, so in hindsight, Amazon did the right thing. It was a very bad security bug in the Zen virtualization software, where if they didn't do this and there was a zero-day flaw, everyone on AWS could have been hacked. So in a way, yes, it was a little annoying. It kind of was inconvenient, but hindsight, it was the right thing to do.
Thank you very much.
Thank you, everyone.
Thanks.
If you have more questions, we have a booth. Come on over, and we'd be glad to answer your questions.